Ever wonder how your phone knows exactly what song you want to hear next? Or how Netflix recommends that perfect movie for your Friday night? It feels like magic, but it's actually the power of machine learning, a key part of artificial intelligence that has exploded in recent years. But this overnight success was actually decades in the making. Today, we're diving deep into the fascinating history of the machine learning boom, story of brilliant minds, frustrating setbacks, and a revolution that's changing our world. So, how did we get from simple calculators to computers that can learn, create, and even dream? Let's find out. The story of artificial intelligence really starts to take shape in the 1950s, at the famous Dartmouth Conference in 1956. The term artificial intelligence was officially coined. Early pioneers like Arthur Samuel were already creating programs that could learn. His checkers playing program wasn't just following rules. It actually got better over time by playing against itself. Another key figure was Frank Rosenblatt, who created the perceptron. This was an early attempt to build a machine that mimicked the human brain, a single-layer neural network. It was simple, but it was a revolutionary idea. People were incredibly optimistic. They imagined a future with thinking machines just around the corner. But this early excitement was about to hit a major wall. The 1970s brought what's known as the first AI winter. The initial hype had set expectations way too high. The computers of the time were just not powerful enough to handle the complex calculations needed for true AI. A critical book by Marvin Minsky and Seymour Papert pointed out the severe limitations of simple models like the perceptron, showing they couldn't even solve some basic problems. Funding dried up, and research in AI, especially neural networks, went out of fashion. It was a time of disillusionment. The dream of intelligent machines seemed to be fading, and the field entered a long period of quiet, almost forgotten research. But even during the AI winter, a few dedicated researchers kept the flame alive. The 1980s saw a quiet resurgence with the development of expert systems. These were AI programs designed to mimic the decision-making ability of a human expert in a specific field, like medicine or finance. They were successful in niche areas and showed that AI could have practical commercial value. More importantly, behind the scenes, a breakthrough was brewing. Researchers like Geoffrey Hinton, David Rumelhart, and Ronald Williams rediscovered and popularized a crucial algorithm called backpropagation. This was the key to training multi-layered neural networks, overcoming the limitations of the original perceptron. It allowed networks to learn much more complex patterns. This was a game changer, laying the groundwork for everything that was to come. The 1990s and early 2000s were a period of steady, incremental progress. Computing power was growing exponentially, following Moore's law. This meant researchers could finally start experimenting with the more complex neural network models they had theorized about years earlier. We also saw the rise of other powerful machine learning algorithms. For example, support vector machines, or SVMs, became very popular for classification tasks. And we saw the development of things like random forests, which combine multiple decision trees to make more accurate predictions. This era also saw a critical shift: the explosion of data. The internet was creating a massive, unprecedented amount of digital information, text, images, user data, everything. This data was the fuel that the hungry machine learning algorithms needed to learn and improve. Then came the 2010s and everything changed. The machine learning boom truly began. A few key factors converged to create a perfect storm. First, an event in 2012 called the ImageNet Large-Scale Visual Recognition Challenge. A team led by Geoffrey Hinton, using a deep neural network called AlexNet, absolutely shattered the previous records for image recognition. Their model was significantly more accurate than any before it. This was the aha moment for the entire field. Deep learning, which uses neural networks with many, many layers, was no longer just a theoretical concept. It was a practical reality that delivered stunning results. The second major factor was the hardware. Companies like NVIDIA had been developing powerful graphics processing units, or GPUs, for the gaming industry. Researchers discovered that these GPUs were perfectly suited for the parallel computations required to train deep neural networks. Training models that used to take weeks or months could now be done in days or even hours. This accelerated the pace of research and development at an incredible rate. Suddenly, everyone wanted to get into deep learning, The third and perhaps most important factor was the massive amount of data we talked about. Companies like Google, Facebook, and Amazon had been collecting vast datasets for years. They had the data, they now had the computing power, and thanks to breakthroughs like ImageNet, they had the right algorithms. This trio: big data, powerful hardware, and advanced algorithms created the perfect environment for machine learning to flourish. Investment poured in, and the race was on. From that point on, the progress has been breathtaking. Deep learning has revolutionized countless fields. In computer vision, our phones can recognize faces to unlock, and self-driving cars can identify pedestrians and traffic signs. In natural language processing, we have translation services that work in real time, and virtual assistants like Alexa and Siri that can understand and respond to our commands. Models like GPT-3 and now GPT-4 can write essays, create poetry, and even generate computer code. Machine learning is also transforming science and medicine, helping to discover new drugs, diagnose diseases from medical scans, and understand complex biological systems. So, where do we go from here? The machine learning boom is far from over. We're seeing new architectures and techniques emerge all the time, like transformers and generative models. The focus is shifting towards creating AI that is more efficient, requires less data, and is more explainable and trustworthy. We are also grappling with the important ethical questions that come with this powerful technology: issues of bias, privacy, and the impact on jobs. The history of machine learning is a story of human ingenuity, persistence, and the incredible synergy between ideas, data, and power. From a simple checkers program to models that can generate art, we've come a long way. The next chapter is still being written, and it promises to be even more exciting. Thanks so much for watching. If you enjoyed this journey through the history of machine learning, please hit that like button and subscribe for more deep dives into the world of technology and science. Let me know in the comments what AI application fascinates you the most. See you in the next video.